What's up? Happy Sunday. Welcome to the stream. Today I wanted to do some Golang linting. I'm thinking that maybe I should have a rhythm. On Friday, I do cockroach DB related DB stuff, and on Sunday I do Golang stuff, maybe. All kind of related, but it's kind of a fun thing. And I think it gives me an opportunity to make sure that I'm not only doing work on my stream. So that's a goal. I have a new project. The new project is this thing called gcassert. And the idea of gcassert is that, well, first of all, the font is too small, so let me fix that up real quick. We like 26 size font on this stream. So the idea with gcassert is that it's going to be a library that allows you to assert that the Go compiler is making certain decisions about your code. My execgen thing has a bunch of similar directives and assertions, but part of the reason that we did execgen in the first place is to work around the fact that Go doesn't really have this flexibility to allow you to say to the compiler, please inline this, please make sure that the bounds checks are eliminated on that. So I thought that, I spend a lot of time looking at that compiler output, and I feel like I also spend a lot of time making sure that my code stays a certain way. Like functions are always inlined in a certain way, or certain slice accesses are always getting their bounds checks eliminated. So I figured I'd write a linter to make sure that I don't ever have to look at that stuff again. Yeah, bounds checking. Well, it's so important. It's crazy how important it is. It's vigorous, but it's like, it'll make your code go from X speed to X over 2 speed. So like, I don't know, I think it's kind of important. So here's what we're gonna do. We're gonna make this window big. We're gonna make some test data. And then inside of test data, I'm gonna have a test file called inline.go. I'll have an inline.go and also a bce.go, because those are kind of the two cases that I'm interested in linting. Yeah, exactly the same thing. Well, I guess different, but similar about just like small changes to your code having outsized effects on the performance of your code. Okay, so for my test data, I'm gonna have something that looks like this. I'll have package main. I'll have a function called inlineable. It'll take an a int and it'll just return nothing, and it will do something. Well, no, it'll return another int, and it's just gonna return a plus 2. And this thing I want to have gcassert inline. No, wait. I guess I want the assertion to be not in the function definition, but in the call site. So I'll have func caller, and I'm going to say for I in range, well, I'll say for I is equal to 0, I is less than 10, I plus plus. I'll say, I don't know, I'll just make some little dumb function basically. Sum is equal to 0, sum plus equals inlineable of I. And then the point is that this line, I want to say gcassert inline, and what my program's going to do is it's going to compile this and make sure that this function is actually getting inlined by the compiler. And if it doesn't, it's going to throw an error. And this is going to allow people who write Go code to make sure that functions are getting inlined. So that's basically the plan. Well, that's for the inline one. Let's also write a test case for the BCE one, because it's going to be similar. So func, I'll say package main, func, a loop. It's going to take no arguments and basically do nothing. I'm going to say for I guess I need to have some sort of sync here as well, because it doesn't really work otherwise. Well, no, here's what we're going to do. It's going to take in a slice, ints, slice of int, and it's going to, for I in range ints, sum plus equals ints of I. return sum. Okay, I'm making the function do some stuff. But the point is that this line here, I want to have an assertion that's called gcassert BCE or something like that. I don't know, maybe that's not that easy to understand, but the idea is that I want to make sure that the compiler is in fact removing the bounds check from ints, because it can infer that this I variable here is always going to be within the allowable length of this slice, no matter what the slice is, because that's how range works. This is like a special, the compiler can recognize this pattern and not have to insert a bounds check when it's doing this access. So that's the goal. These are my tests. And so I guess since we don't actually have any code yet, maybe we could start by writing the test cases or something like that. Or the test harness, I suppose. So I'll make a new file called, I'll just call it gcassert test, I guess. And I'm gonna make a func test See, I guess, let's see. Do I want this thing to just run over both files, or do I want one test case per file? I'm thinking I'll just call this test gcassert for now. I don't know. Testing.t. And so what this is gonna do is, well, I guess it'll actually have to call our API. Whatever our API is gonna be, I suppose I should define that now. Another question that I don't really know the answer to yet is whether I want people to use this thing as a library, so to be able to invoke it from their linters, or to be used as a program to run it on a package. I kind of think that it would be easier to make it just run on a package, but I think that for the purposes of this, I should probably have an API as well so that I can test it effectively. So I guess, let's see. I guess I'll have a, let's see. So what's the, I'll just call this gcassert, I guess. And the arguments are gonna be the package path, I guess. Path string. And the results will be, I guess I would really want it to have like a map somehow of lines of code that violate the thing or something like that. Actually, maybe for now I don't know what I'm doing yet. So maybe I'll just pass in a path string and have it print out its exceptions so that we don't have to worry too much yet about what the signature of this thing is going to be. Let's turn this down a bit. Let's turn this down a bit more. Okay. So the way this is going to work then is I'm going to use this good old AST library. I'm not going to use, I don't know if I know Sartak's been paying attention to this whole Dave syntax tree business. I'm not going to use that now because it has problems getting you back the like token positions of the things that it reads in for some reason. It like gets rid of that information because it wants you to be able to actually edit it, I guess, and it doesn't want to keep track of all of that information. So it just sort of throws it all away. But the normal AST library gives you back the token positions, which is nice. Hey, Cypher, what's up? Thanks for the positivity there. And thanks for that little doggy pride afro or whatever. Oh no, this is your emote. Sig Afro K, I like that. Thing is pretty, I like it. I don't even know what it means, but I like it. Anyway, so I'm gonna parse in this path. And this thing is gonna return, oh, this thing takes a lot of arguments actually. So I guess I need to get a token.file set. Maybe I'll capture this guy, file set. So it's gonna take in this file set, it's gonna take in a path, then it needs a bunch of other random stuff. Filter. If filter is not equal to only in the files with OS of file info entries passing through the filter. Oh, I see. I don't think I care about that. And mode. What do I need mode for? Mode is a set of flags. Oh, it lets me choose what kind of stuff I want. I guess that seems useful. It's actually an existing product mascot thing in Japan, Afro Ken. That's cool. So Go parser gives me back an AST. The packages sort of work together. I don't think you can get an AST without using Go parser. So I'm gonna pass nil for this filter. And then for the mode, I guess I need to kind of assemble one of these. Do I like OR these together? Parse comments, spurious errors, trace. I think I just want parse comments. Token.parse. No, is it not token? Parse comments? What was that? Parser.parse comments. Okay, so this is gonna give me back a map of strings to packages and an error. So package map error is equal to, and then I'll say if error is not equal to nil, I'll just panic here because I don't really care yet. And then for package map, I guess the idea is that really I was expecting this thing to just give me back a single package. So I wonder, does this do sort of a recursive parsing thing? Parser calls parse file for all files with name ending in .go in the directory specified by path and returns directory. It doesn't really tell me if it's recursive or not, I feel like. So I don't exactly know why it would give me back a map of packages, to be honest, but that's okay. So I'll say for package name, package in range, I guess this can't be package, it's gotta be pkg in range package map. I'll call this pkg name. Now what do I want to do with this package thing? I want to look at its files. I don't care about its string or its name or its scope, whatever that is. Packages scope across all files. Oh, this is cool. So this is actually doing some more advanced language analysis for you, I guess. I'm not sure. But basically I want to say for I in range package.files. I guess it's file name file in range package.files. Yeah, so here's the thing. Like, I need to do a couple things here. I need to get out all of the lines of code that are annotated with these special comments. That's the first task. So first, find all lines of code annotated with our gcassert directives. And then it's going to be next I actually have to compile the packages. And this is like probably the messiest part that I'm like probably least excited about. But basically I have to invoke Go compiler with -m flags to get the compiler to print its optimization decisions. Now you might think that this is a little bit of an odd way of going about things, but to be honest, I actually went before the stream and I checked out what the Go compiler itself does for its own tests. And I'll tell you that it does exactly this. I'm gonna show you just because it's kind of funny, I thought. So if I grep for, I think it was like find.grep inl test, I think it was the name of the file. Yeah, so if I guess I already have it open in another window, huh? So here's this file, inl test.go. And this is the test in the Go compiler for its inlining decisions. And the way it works is that it runs go build and passes in these GC flags. So it's actually, it doesn't like, invoke the Go compiler from code or anything like that. Even though I think it could, it just shells out to go build with GC flags equals all. So that's what I'm gonna do too. I'm gonna shell out to go build. And I'm probably gonna copy sort of what's going on here because they already set it up for me, which is kind of nice. So next I'm going to invoke the Go compiler with -m flags to get the compiler to print its optimization decisions. And then the final step is for every optimization decision that matches a line of code that we found earlier. I guess it's sort of like decide whether our assertion passes or fails. Decide whether, the assertion for that line passes or fails. Okay, cool. So I guess the first step, let's just do this first step first. And this is going to be the most, sort of the parser task. And these next and finalies, they probably are going to occur somewhere else, is my guess, but I'm not sure. So let's see. I guess this is where we're gonna have to do a little bit of a walking thing. So let's see if they've got that same pattern in AST. I think they do. So I think we can pass in a visitor, which we'll define, and then a node, and I think a file is a node, possibly. Let's see. So what is a visitor? A visitor is a interface with a visit. That's it. Okay, so pretty straightforward. Let's copy this interface, and maybe we can make a new struct for this. So we'll call it struct gcassert. Well, I'll just call it assert visitor. Whoops, that's not how we define structs in Go. And we're going to implement this visitor interface because that's just a handy thing to do. And this is where we're going to actually write our code. So I think really what we want to do here is actually we don't even need to inspect the node. I don't think we just need to inspect its comments and then inspect its position and then associate the comment or associate the position with a assertion if it exists. So again, this comes back to now figuring out how to deal with those comments. And I looked this up ahead of time. There is a way to do it that I think it's this new comment map thing. Except we have to get at this comment group thing as well, which I forget. Do I get a comment group from a file? Or no? Okay, so a field has a comment group. A file has a comment group. And a comments, I see. So here it is. Each file has list of all comments in the source file. So that's like medium convenient. And I guess what we'll do up here is we'll say comment group is equal to, or it's comment map rather. Comment map is equal to new comment map. And then our file set is this thing file set. Our node is going to be our file. So I suppose we have to do it inside of this loop. And then our comment group is going to be file.comments. Now it kind of makes me wonder what is this node doing in here exactly? Let's read those documentation here. New comment map creates a new comment map by associating comment groups of the comments list with the nodes of the AST specified by node. Okay, so I think it does make sense for me to pass the whole file into here. So we'll stick with that and see if it works. And then what does a comment map give me? I can get all the comments out. I can get strings, and I can get a filter. Now what is filter? This sort of seems like the thing that I want. Filter returns a new comment map consisting of only those entries of CMAP for which a corresponding node exists in the AST specified by node. Well, that's a kind of roundabout way of saying it, but I think that might be what I want. Let's see, comment map. Yeah, I think what I do is I pass in an AST node to this filter thing, and then I can get out its comments, essentially. A little wonky. Why don't we try it? So we're gonna say, I guess that's what we're gonna do in our visitor too. So we're gonna construct a fresh visitor, and I think we need our comment map inside of it. So we'll say comment map, ast.comment map. I think I probably, does this have a pointer? No, this is just a raw old comment map. So I'm gonna make a v is equal to assert visitor. Comment map is gonna be my comment map. And then I'm gonna walk with this visitor. And then we get to decide what our visitor does up here. And I think what I'll say is that I'll extract all the comments for a particular node. So I'll say a.commentmap.filter node. And then I'll say m.string or m.comments. I think I want to do the list of comment groups in the comment map. I think I'm going to want to do this comment groups guy just because it'll be easier to parse. So I'll say for g in range m dot comments. Wait, oh, I guess it's like this. And then I'll say for c in range g dot. Yo, Lithium, what's up? Because of you, I went and redid my entire vimrc. That sounds like a lot of fun. Any cool snippets to report? And then I guess I'm gonna need a couple of regexes now. And let's see. My regexes are basically gonna look like, it's similar to what I did in that other thing. So maybe I can just go copy, well, I probably don't need to copy it. I can just say var assert inline is equal to regex dot must compile. And it's gonna look like gcassert inline. So very simple. And then same for the other guy, assert BCE, gcassert BCE. I just learned how to comment multi-line visual block mode, and I set up some cool shortcut standard Vim Go. That's awesome. Yeah, there's some good. I think there's like a plugin for doing like comment grouping and mapping. Why am I saying that? It's not grouping and mapping. That's what I'm working on. I mean, like, I think it's like language specific commenting or something like that. It's called like Vim commentary, I want to say. Yeah, this thing. All of T-Pope's Vim plugins are gold. Nerdtree has a comment plugin. That's cool. Anyway. So I guess for each of these comments, I'm going to check to see whether they have one of these. You know, maybe what I should do is actually just match it once, like this. GC assert regex, and then I don't have to match multiple regexes at the same time, which might be kind of nice. Baby awake. Have a fun 2 minutes. Hey, thanks for stopping by, man. You love to see it. Whoa. You have, like, your emote game is getting really advanced. That's really awesome. Okay. So let's see. I guess I'm going to say gcassert, what is it? regexp dot match string. It's not match, right? It's like, what the heck is it? I always forget this. Golang capture matches regex. Capture. I think it's this find string submatch, right? Find string submatch returns a slice of strings holding the text of the leftmost match and any of its sub expressions. Yeah. Okay, so we'll say find, no? Oh, right, it's a method on gcassert regex. Find string submatch. Why don't I have the non-index variants here? Oh, here it is. Weird. Okay. So this is going to take in the comment, and it's going to take in 0 to give me everything I want to say. This doesn't tell me what n is. I guess I don't need all. I think I just need find string submatch, and then that doesn't take the n, I think, right? Yeah. Okay. There we go. So matches is equal to this. I guess this needs to be string of C or something like that. C.text rather. Okay, so then I'll say if matches, I guess I can say if len matches is equal to 0, then I return, yeah, then I just return, I guess, right? No, I guess I have to continue through my comment loop. So I'll make a label up here, comment loop. I love to make myself a good loop label. Continue comment loop. Typo in word comment loop? Don't be a freak. That's crazy. Okay, so otherwise, the 0th match is the whole string, and the first match is the gcassert directive. So then I think what we're going to do is we're going to build up a map, like a directive map, essentially. Directive map from, let's see. So when we're ultimately trying to match up our comments with the compiler output, I guess what we actually are going to be looking for is a file line pair, I think. So that kind of makes me wonder. Let's see. So these pose, right? Token.pose. What is a token.pose? Does it contain file information, or is it just an integer? It looks like it's just an integer. So really what I need, presumably, is a map from file to position to directive. But I think that this visitor is working just on a single file at a time. So I think I'm going to make this map from token.pose to what? Maybe we might make a little enum. So we'll say type assert directive int. Then I'll say const. I'll say, let's see. So the first one's going to be inline assert directive equals iota. And then I think I can say BCE. And then this is going to give me two consts. This one's going to be 0. This one's going to be 1. If I keep adding ones underneath it, it's going to renumber them. So this is just a way to have an enum in Go. Okay, so this is going to be a map from token.pose to assert directive. Perhaps a list of assert directives, in fact, because we might have an inlined and BCE'd line. Why not? So I think we're also going to need to have a little constructor. So we'll need to say func string to directive. I mean, maybe it's really pointless to have these be enums. I don't know. S string assert directive switch S case inline return inline case BCE return BCE. I think there's even an easier way to do this, but I forget. And then otherwise we'll say panic. No such, well, it's not a panic, right? Because somebody might just put a stray directive. So this will have to return an error. Or maybe what we want to do is actually have a no directive, assert directive equals iota, something like this. So that the caller can ignore it or something like that. I don't like that. I'm gonna have it return an error. Crystal Gamer, you're the first person I've seen with it. Besides typing, does it fare well in gaming? No, this is not really good for gaming, I don't think, because it's like too clicky. The keys are too deep. But you can read more about that with the exclamation point keyboard command. So for this, I'll just return, yeah, I guess I do sort of want a no directive equals iota. Cool, so this was gonna return no directive and errors.new, no such directive. I guess I want it to be an errors.errorf. Error new f, what is it? Could have sworn there was something for this. Maybe that's our custom library. Format.sprintf. Like this. Dropped frames? I don't know. I hope it's just you. The bitrate lines look clear to me, but let me know if you're seeing drop frames Anybody else? Okay, so we've got that. And what we're going to do is we're going to grab our string to directive. So we'll say directive is equal to string to directive of matches of 1. And I guess this is directive comma error. If error is not equal to nil, we're also going to continue loop or comment loop. Great. And then if we don't get an error, then we're going to associate the current position with our directive. So we'll say visitor.directiveMap. No? Oh, this is an A. I guess this should be a V. It's a little bit more canonical. So v.directiveMap of node.position. Now, does this give me... This is a little bit not great because I think this position is actually including the position within the line. And I actually just want to have the line number itself. And I think that this thing lets me extract out the line number. I'm hoping. Yo, Crystal Gamer, thanks for the follow. I need to figure out how to get the line number out of this post. I'm not sure how to do that. I think the file set itself has some methods about this. Let's look at our file set, just out of curiosity. So file set dot position, right? No. Okay, so if I call fileset.position on something, it gives me back a column and a line. So that's great. So that means I guess my visitor is also going to need to have this file set, right? So file set. Make a field for this. Cool. Okay. So I guess what I need to do then is in my visitor, what I'll do is extract the line number from the file set. So I'll say v.fileset.position of post.line. So I'll say line number is equal to this. I'll say directive map. And I guess the directive map at this point is not a post map at all. It's just an integer map. So I'll say map from integer to slice of assert directives. So I'll say v.directive map of line number. And then the question is, I guess I can just assign like this. So I'll say v.directive map is equal to append, then the same thing. Because in Go, if you ask for a the entry in a map at a non-existent key, it's going to give you back the 0 value for the type of the map, which in this case is a slice, and the 0 value of a slice is nil, and you can append to nil, and it's going to give you a new slice. So this is sort of like a valid way to have a map of slices without having to, go about doing the like default map dance if you're used to doing Python or whatever it is. So we're going to add a new thing to our slice, which is going to be the directive that we just parsed out. So I think that's all we have to do here, to be honest, right? One thing that I'm a little bit confused about is why this visit method is supposed to return a visitor. That's highly confusing. What does that mean? A visitor's visit method is invoked for each node encountered by walk. If the result visitor W is not nil, walk visits each of the children. Oh, wow. So you can actually edit the visitor if you feel like it to recurse further. That's kind of interesting. But I think in my case, I just want to return myself. So I'll just down here, I'll just return V. And then I think that is going to be my visitor recursion. I can get rid of this filter thing because we're doing that down. Wait, can I? No, I can't. Okay. I think that's probably that. So we're going to walk through our file. We're going to assemble this map. And then I guess what we want to do is make another map up here. So we'll have a file directive map or something. It's equal to make. Ooh, speaking of that, I actually need to make sure that I initialize. You know, I should probably just make a constructor for this visitor at this point because it's gotten kind of complicated. So let me make a quick constructor. I'll say func new assert visitor. This can be lowercase too because I'm not exporting it. It's going to take a comment map, ast.comment map, a file set, token.file set, and it's going to return to me an assert visitor. And it's just going to just return a new assert visitor, filling all the fields except for my, for my directive map, I need to actually construct a fresh map just because otherwise it's gonna nil pointer when you try to index it. So we'll say make map int to slice of assert directive. Cool. So then when we actually get this visitor, we can just call our constructor instead of assembling it ourselves. So new assert visitor, comment map file set. So that's a little bit nicer anyway. So for our file directive map, what we want to do is make a map from file name. So it's from string to map of int to, you know, maybe what we should actually do is instead of having this deeply nested map, I can just have a single flat map. And that instead of having an integer key, it actually has a key that has the file name and the file position inside. Does that make sense or does that not make sense? I think it means it's going to be a little bit more annoying to look up into it though, because you'll have to keep constructing these keys instead of just being able to iterate over an entire file. So never mind. Forget that thought. It was a wrong thought. I'm just going to go for this double map thing. Okay, so we have our file directive map. And what we're going to do is for every file, we're going to make a fresh entry in this map. So we'll say, I guess what we'll actually say is file directive map of file name is equal to v dot directive map, right? I suppose that this is also a little bit troublesome because I'm not entirely sure whether this file name is going to include the package path, which means that this might be flawed if we are trying to do multiple packages at the same time. But I don't know, I'll leave that for later. Speaking of annoying, let me quickly set up reformat on save in this project. I don't know why that's not done, but it's a little bit disturbing. Okay. So now I think if we save it should, okay, that's a bit better. Okay, cool. So we've got our visitor, we've got our assert. I guess the next step is that we need to actually run the compiler.
I'm not going.
But maybe we should run some tests on this first. That could be a good thing. So let's make a new. I guess we had this gcassert test file. We can write it in there. So we're gonna have, this will be called test parse directives, and it's gonna say, hey Falcon, thank you for the follow, by the way. I'm not sure. It seems like on Sundays my Streamlabs alerts sometimes don't work. I don't know why. It's a little bit annoying. It's like unclear to me why that happens. I just clicked refresh on that alert like 5 times and nothing happened. I wonder if I actually go and I think what I did last time is I refreshed the cache of the alert page or something, and that fixed it. Let me try that real quick. These alerts are important. There we go. Okay. Crystal Gamer, if you're still there, there's your alert. And Falcon, I don't know. For Falcon, I can't refresh it because I think I did it too many times. But anyway,
computers hooked into over 1,000 databases
there we go.
throughout the world.
Okay, cool. Anyway, back to coding. So test parse directives, right? What this is going to do
computers
is I need to
over
walk
1,000
through.
databanks throughout the world.
Okay, this is the revenge of me clicking it multiple times. I need to walk through this test data directory.
Computers hooked into over 1,000 databanks throughout the world.
Oh dear. Oh dear. Directory walk.
Databanks.
Now I need to like pause the alerts because I clicked it too many times, huh? Okay, so do I just call walk? Is that how it works? I just want to list the files in a directory. How do I do that? Do I have to use walk? Golang list files in directory. IOUtil readdir. It sounds legit. If you're watching this and just getting into programming, my message to you is that Googling things like this is a constant fact of life. I hear a lot of people wondering whether people just know things in their head, and the answer is that no, they don't. Okay, so we're gonna go like this. Yeah, thanks, readdir. I think I'm gonna use this readdir thing. Sometimes like there's like IOUtil readdir and like file path readdir. I don't know. I found that the IOUtil things it's like a slightly higher level API. So if I pass in test data here, and then I say for I in, well, you know what I really could do? Oh, you use this week at work? That's cool. I guess what I'll need to do is kind of make this into a little function. So I'll make this guy into a function. So this is going to be called parse directives. And I'm going to say, I guess what I'm going to do, I guess I can literally just run this exact code here. Forget readdir, I don't really need that. I'm just going to parse test data like this, and then call package map file set. And then I guess parse directives needs to be returning this file directive map. I wonder if it's time to define a type for this huge map thing. Probably. Okay, let's define a type for this thing. So I'll call it type, let's see, file to, I'll just call it type directive map maybe. So map from string to map from int to slice of assert directive. Okay, so we've got our directive map, and this thing needs to return it to. So down here, we'll just return file directive map like this. And then in main, we're gonna say file directive map is equal to. I guess we don't use it yet, so it's not gonna compile. We'll just get rid of that actually. But over here, we're gonna grab it out. So directive map is equal to. Okay, and then I guess what we want to do is I guess we can just sort of have some hard-coded assertions about the directives. So we'll say for I in range. Well, is this really how we want to do it? I guess it's, I mean, it's not the worst thing. So for f in range directive map, yeah, it's like, I guess what we could actually do is literally just hard code the map. How about that? That would be a better thing. So expected map is equal to map from string to map from int to slice of, wait, I literally already have a type for this. Are you allowed to use type, like map type literals as literals in a sense? Like, can I say directive map like this, or not really? It doesn't really look like it. So the map is gonna have, let's see, what's in my test data again? So it's gonna have a map from BCE to, and then let's see, so line 7, this is supposed to be a plus equals, by the way, is supposed to have the word slice of, well, I guess it can just be like this, BCE. And then for the inline one, it's gonna look like line 11 has an inline assertion. I don't know, this is a little bit nasty, but what are you gonna do? So assert dot, wait, we don't have that library in here. Should we just import it? How do I, let's see. This is also like my Go modules education when building a library. So I'll say go get github.com stretch testify, I think is the name of it. No? What is it called? GitHub testify. Stretch R, excuse me. Slight typos will get you every time. Okay, so I think my go.mod will now have an entry for testify. Cool. So then in my program, I can use it, hopefully. Assert dot equal. Is there like a map compare? Let's see. Testify map compare Golang. Oh yeah, they've got reflect.deep equal. Okay, forget testify. It's not even necessary. Reflect.deep equal directive map, comma, expected map. So if not, then we'll say t dot fatal f expected this, or v, I guess, got this. And I'll put a new line just because it's going to be a lot of output, I want to say. So expected map, directive map. Cool. Okay, let's run the test. So go test dot. See what happens. AST.walk unexpected node type nil. Okay. I can use assert equal on map. Okay, I'll do that. So expected directive map. Okay, so the question though is, what is the deal with this panic? Unexpected node type nil. It says to me I am possibly just misusing this API altogether. Why would this be nil though, right? It's like, it's a little bit unexpected. Maybe it's sort of an expected.
Data.
Hey, Yettenek Siz Yazli MCI. Thank you so much for the follow. I don't think I get that name, but it's cool. Okay, so I see. It's expected that the last thing that we do is call visit with nil. So I guess I just have to quit when that happens. So if we go back up to our visitor and we say if node is equal to nil, I'll just say return W. It means untalented developer smiley face. Okay. So it's not equal, and we get a bunch of interesting looking stuff. Expected was this, actual was this. And it looks like our directive map has full file paths instead of just names. So that's actually sort of nice. I was hoping that we would get that, and we did. And in fact, they include the .go suffix as well. So we'll keep that. Okay, so it's still different. Interestingly, it seems to have a lot more entries than I was expecting. So it sort of seems like something's going wrong with my... Can I like print this out in a little bit of a less gross way, I wonder? Maybe not. So, for example, in the BCE file, it's telling me that at line 1, I have a directive of type 2, which is not true. And at line 3, I have 2 directives, both of type 2. So something is just going wildly wrong, I want to say. So let's figure out what the deal is with that. Oh, you know what I think it is? I think it must be that... these comment groups are included in multiple AST nodes or something like that. Why don't we find out though? So inside of our assert visitor, let's print some stuff out. We'll print out the comment group essentially at each node. Yeah, so I'll say format.println at node, and then I'll just print out, or I guess I'll print out the node and then the comment map itself. See what that gives me. So it's giving me, I think the issue is that, well, yeah. Okay, so check this out. It's saying that at package main, it's actually including the comment map for all of the lines in the file. So that's trouble. So I think, what if we just were to skip that particular type of thing? It still kind of seems like, yeah, every parent node contains all of its children, which is really not great. Not really that great at all. Let's try to understand how this comment map thing works a little bit more. Filter returns a new comment map consisting of only those entries of CMap for which a corresponding node exists in the AST specified by node. Yeah. So it's not good. Because that means like, okay, so for example, if I look in inline.go, I think what this is telling me is that this AST node, like the top dog of this file, is going to include this comment, as well as this declaration, the func declaration, as well as this for loop, because they're all, it's like this parent-child relationship stuff. I don't like that whatsoever. Maybe, let's go back to our documentation for this AST thing. Maybe that would help. So for example, this is how they are. This isn't exactly the example that I want, to be honest. The example that I want is really about like, how do I figure out what comments are associated with just the node, not like the children of the node, but just the node, right? I mean, I guess I could look at how this thing is implemented. It doesn't make me that happy, but I guess we can look at how comment map is implemented, or comment map filter rather. It says inspect. Walk. So walk is what we're using already. And the visitor that it's using is this inspector. And the inspector, huh? Inspector of F. Oh, I see. So the inspect is taking a function. So I have to look at this function here. I see. So it's saying for every node in the AST, if I look up into the map, if len of g is greater than 0, u map of n. Okay, so I guess this map is already doing the wrong thing in a sense, and I have to look at how this map is constructed. So how is this new comment map? New comment map tries to associate a comment group to the largest node possible. For example, if the list is a line comment trailing an assignment, the comment is associated with the entire assignment rather than just the last operand in the assignment. Okay, that doesn't really sound right. New comment map by associating comment groups with the comments list with the nodes of the AST specified by node. It's associated with the node if G starts on the same line as N ends. G starts on the line immediately following N, and there's at least one empty. Well, I mean, this is kind of implying to me that it's not like it's doing the thing that I was expecting, and not this kind of more odd way of doing things. So don't really get that. Oh, you know, wait. I think I know what I'm doing wrong, you guys. It's really simple. This filter API is not at all relevant. I think all I need to do is actually look up, like use the comment map as a map. So I think it's actually really straightforward. I think I say m is equal to v dot comment map of node, like this. No, is that not right? Cannot assign comment group to. It's a slice of. Just get rid of this. Oh, there we go. Okay, so that's better. Okay, let's try this again. I think it maybe will work now. That filter thing, I think, is just a little bit more complicated. Okay, so we have a different failure now. Our expected had bce.go with 7 to 2, and we got back bce.go with 7 to 2, so that's good. And then inline.go contained 11 to 1. Oh, so this is actually correct. And so what's the matter then? Oh, we expected it to be a... I see. I think it's just a matter of type differences now. So if we go back to our gcassert test and change this to be a directive map. See, that doesn't work. It's a little bit gross. Oh, wait. Actual map, we can call it. Actual map is equal to this. Actual map. Okay, there we go. Now I think the test will pass. Yay! Okay, good progress, good progress. So our test parse directives thing is going to be working well now. The next thing that we need to do is actually invoke the compiler and grab its optimization decision. So for this, I'm going to copy what the Go compiler's tests actually are doing, like I was saying earlier, just so I don't have to refigure this out. So I'm going to grab these arguments. I think I'm just going to grab this entire thing because realistically, it's actually kind of tricky to set up. Let's see. So we don't need this stuff. We want just exec.command. I guess it's going to be go and arg ... I always have a hard time doing shell outs from programming languages because they always have an odd way of doing things. So I guess this is going to take just path. Get rid of this tags thing because it's not at all relevant. Then what else do we do here? Then we have a scanner, and we look through all of the stuff. So that's straightforward. I think we want to grab all this stuff and change some things. We don't need to care about can inline. We don't need to care about cannot inline. We just want to care about have inlined. And then we're going to say, I don't know what cur package is for, so we can ignore that for now. So for, what is it? Scanner dot scan? This is a new API for me. So I guess I say line is equal to scanner dot text. And then I've got a line to examine. And then I can run my regexes on it. So I can say have inlined dot match string line. So if this is the case, then I need to figure out whether or not there was a matching. Well, I guess I need to do a couple things. I need to pull out the actual line that the compiler outputted. So let's look at some sample output, shall we? I think if I say go build dash gc flags equals m dot, it'll print me out this format. So I think what I need to do is parse this first part. Yeah, this is a perfect example. So let's grab this text and use it as our example here. So I guess what we need to do is actually search for I need to care about the file name itself. So that would be, I guess you can have a dot, you can have a slash, and you can have any word. And then I would need a colon, and then I have some numbers. Which is dash D, is that what it is? Can't remember. Regex tester, let's go. Do some regex tester. Let's just grab this whole thing, why not? Guess I need a plus, obviously. No. Is D right? Yeah, D is right. What's the deal? Why no good? What if I get rid of... Is it something to do with greediness or something? I don't know. Inlining call to blah. Let's get rid of this thing. I don't care. Get rid of this. Just make it super simple. So none of the special characters. Oh, it's because I can't have... Is it because I can't mix and match square brackets? And that's probably what the issue is, right? So I have to say A through Z, A through Z. No. It's because I didn't actually match it. That's another issue. This needs a plus. This needs a plus. Yeah, exactly. I do need another. This needs another colon. I would be failing the regex Olympics right now for sure. Oh, there we go. Okay, so that is kind of working. And I guess this needs to be like this. Okay, here we go. Here we go, here we go, here we go. So I was all messed up. So then I can add back my dots and slashes. There we go. Okay. We good. So we check if we've matched the string. I guess then again we need to capture our groups again and whatnot. So this is going to be match or find sub match. Oh, I can? Oh yeah, you're right. I guess I must have been missing some other thing and I was getting confused. Thank you for that. Okay, so I'll say matches is equal to have inline find match. If len matches is equal to 0. Or I guess I can say not equal to 0 because they're gonna have several of these regexes to match, I think. I'll say, let's see, so file name is equal to matches of 1. I guess it's really file path. And then line is equal to matches of 2. And then I guess what I need to do is take a look at my directives map. And then I need to say if line to directives is equal to directive map of file, whoops, directives of file path, and line to directives is not equal to nil, then we do the same thing for the line map. So if directives is equal to line to directives of line and directives is not equal to nil, and let's rename this outer directives thing. So this is going to be file to, I don't know, directive map. I'll just call it that, I guess. What's wrong with this? Oh, this is a string. I guess I need to A to I it. What is it again? A to I, strconf.a2i. So if this is an error, I guess I can just panic. I don't know. It's not a normal case. Now, if this is the case, then it would be ideal if all of these things had the same format. Do they? It kind of seems like they do. This auto-generated one is sketchy, but we can ignore that. So I think what I want to do is do a single outer regex. So this is going to be the, I guess it'll be the like opt info regex. So for this, we're just going to capture this preamble thing and then everything else in the final group. And then we can have separate regexes for the, sub matches inside of here. So we'll say match is equal to opt info dot find string submatch. We got our file path, we got our line. And then inside of here, then we basically are going to run all of our other regex matchers. So for that, we're going to be looking for inlining call to. And then the other one that we care about is the bounds check eliminator, which I forget what that looks like now. So let's find out. There's a chance that I'm not going to be able to do it with just this one debug output, but I don't remember. So let's just try to make this compile and we can rerun it for a sec. Okay, so let's actually just well, let's just run like this, see what happens. No new variables on left side of thing. Just fix that real quick. Just comment this whole thing out. What if I run it against test data? Does that work? Build output test data already exists in as a directory. I think it's because test data is like a special thing. But I really do want to, let's just go like this then. Okay, so it says, let's make this not package main, package test. Package gcassert. Maybe. Yeah, bummer. It doesn't have the output for the bounds check elimination, which means that I need to run also with another, that like long flag thing that I always kind of forget, like this. So I need to put -m and then also -d equals SSA check BCE debug equals 1, I guess. Kind of unfortunate. Huh. So that's also not including the output that I was expecting. Why would that be? Why would that be? What if I just include the -d only? I don't get any output. That's actually slightly surprising because I've used this so many times. Is it? Just need to make sure that it's actually force rebuilding of packages that are already up to date. Okay, so that's what I was expecting. Maybe it's just like this function isn't complicated enough or something like that. Hey, JB Pratt, what's up? Thanks for stopping in. How you doing? I do kind of expect this would work. Maybe it just needs a caller or something like that. So no, I don't think so though, because there's no main in this or anything like that. Let's just make sure. So a loop make int 5, something like this, just to make sure that it's actually getting called. So even that doesn't print anything out. That's a little bit confusing to me. Why would that be the case? Check BCE Golang. Oh, you know, the reason is that, right. So it's actually the opposite. I think the issue is that I would need to find one that doesn't have its bounds checks eliminated in order to show what this output is supposed to look like. So I guess what I would need to do is say, like, I don't know, format.println ints of 5 or something like this. What happened there? Forgot a parentheses. Okay, so now I think if we run this, it's going to tell me something, right? Okay, great. So this is what I was expecting. And I guess what's kind of funny is that this particular assertion is the inverse. It's like if we do find a line from the compiler, then we need to check that there wasn't an assertion or something like that. But that's fine. And in fact, the point is that it does obey the same kind of schema in a sense. So we should be able to use the same matchers. So if I run with -m and -d, I should get all of the output. Okay, cool. Cool. So back to programming. I guess what we need to do is copy these found is in bounds lines here. I guess it's going to be like, this isn't even a regex. It's just a simple match. So this is going to be in bounds check is equal to this, and I think there's also one for found slice in bounds. Slice is in bounds, which we should also probably have a case for. Okay. So then what we do is for each of the directives that we found on a particular line, what we need to do is reassociate them back with, it's not, sorry, not each directive. Like what this loop is it's actually pulling these guys out. So I guess what we do is we just say, right, we also need to extract the third match from this regex, which is going to tell me the, like this information, which I guess I could call, what is this? Like the message maybe? So I'll say message is equal to matches of 3. Then I'll say for, and I guess I don't even need to have this if, because looping over nil is valid in Go. So I'll just say for directive in range line to directives of line. And then I have I guess I'll have a switch. So sort of like switch D, case BCE. Now with the BCE, we need to check to see whether the last line had a bounds check or slice bounds check in its message. So for, I guess I can just say if message is equal to bounds check or message is equal to slice bounds check, then this is an error case. We found a bounds check where the user expected there to be none. So I guess in this case, we need to just, I guess for now, I'll just print it. So, and I guess what we want to do is kind of print out the, I guess we could just print out this line. Well, I suppose what we want to do is there's a couple of things. Like we want to print out the user's code line that failed the assertion itself, and the compiler output that proved that the assertion failed. So we'll say, and do we have enough information left though? I think we might have thrown some of that information, right? Like we don't have this code line, I don't think, which means that we need to go back up to our directive map. So yeah, I think essentially in this directive map, instead of having a map from int to slice of assert directives, we want a slice of, well, we really want a struct. So instead of just assert directive, we want also like a, I don't know, type, what would it be? Code and directive or something. And it's going to have a node ast.node and our slice of directives, of assert directives, I guess they're called. All right. And then I guess we've got to change this to be code and directives. Same with this. It's kind of a bad name. I'm really pretty bad at naming, honestly. Right. And now here, I guess what we need to do is say, we'll say dot directives is equal to append dot directives directive. And then the last step, I guess, is going to be, what's wrong with this? Not assigned to. Oh, that's interesting. So even though it's a value, I'm not allowed to assign to. I guess that's like sort of expected. So, so I'll just pull it out and edit it and put it back in. Reasonable. So I guess I'll say line info maybe. Maybe that's a better way of saying it instead of code and directives. Line info. B.directive map of line number. Then I'll say line info.directives equals append line info.directives, comma directive. And then the last step, I guess, is going to be setting line info.n to be node, right? And this is going to get reset a couple of times extra, but I don't think it really matters too much. And then lastly, we need to change this thing to be code and directive. Let's rename this to be line info. How about? And then I guess it's the same thing here. We have to pull this out into a variable. We range over its directives, and then we set. Right, the whole point is that we want it to be able to print out the user's code line that caused the assertion failure. So we'll say, we probably want to make this a function too, but assertion failed. And then we'll print out info dot n dot pose. Well, I guess we'll print out, let's see, I guess it would be, ooh, do we also want the file name in there, or do we already have the file name? I think we already have the file name. Oh, we already even have, we have quite a bit of information. We have, I guess we want to do printf. So we'll put the file name and the file number, and then the line of code maybe. So this is going to be file path, comma, line, comma, and then I guess we need to figure out how to reformat that AST node. So node, I don't know how to do that yet. D dot, wait a minute, no, info dot n. Is there a print here? Probably not. Let's see. So Golang print AST node. Is there like an fprint? Fprint prints the subtree starting at AST node to W. Seems legit. So I guess we need to make a little buff. Var buff strings dot builder, and we'll say ast dot fprint buff and file set and info.n and nil. And then we can say, for this last part, we just say buff.string. Okay, so we've got our line of code that failed. We don't care about this error. And then the final thing is that we need to print out the assertion, I guess, that the user specified. Well, maybe that's going to get included. Now, here's what we'll do. We'll say printf assertion failed, and then we'll print out the assertion in that first line. So it's going to be we'll just print out message, I guess, right? Or maybe just this whole line. What's wrong with this? Oh, line is an int. Oh, we renamed this, so line no. Call this. All right. So I think that might maybe work, potentially, possibly. We could run it. So we'll say func test gcassert t testing.t. Now what's wrong with this? Cannot use inline as type. Oh. No, this is annoying. So the problem here is now that like, since I added that extra information to my directive map, which is like the AST node of the particular line of code that had the assertion directive on it, I can no longer just make a simple map of expected versus actual, because I can't really include that AST node in there practically. Oh, it's very sad. I guess I could just strip them all out ahead of time. I'll do that. So for I in range, actual map, for info in range m, info dot n is equal to nil. Okay, so that's an easy way of fixing it. Just like making my test not really care what's in the actual map at all. And then here, I guess I have to put make this a struct and make this called directives or whatever it's called. What is it called again? Line info has, yeah, directives inside. And this is a slice of assert directive. All right, so that's not great, but whatever. Cool. So I think this is probably going to fail because I've like changed some of these files, but let's just rerun just in case. All right, so the issue. So something went drastically wrong. Oh, I think I know what it is. I forgot to assign the map back to its slot, essentially. Which was over here. So I have to say v.directive map of line number is equal to line info with an equal sign. Can't forget that equal sign. Okay, so let's rerun this guy. And now we have another failure, but I think it's just about line numbers this time. Well, it sort of seems like it still includes that AST node for some reason. So I did something slightly wrong. Let's go back to our test. And so this, first of all, is line 10, which is fine. But the bigger problem is that for some reason this isn't working. I think it's because I've got to reassign back. So I have to say m of k is equal to info. I think that'll fix it, probably. It's a little bit gross, a little bit problematic. Okay, cool. So our tests are passing. Hooray. By the way, if you're just joining the stream, I'm Jordan. We're working on a Golang linter for making sure that the Golang compiler is properly producing inline function decisions and bounds check elimination decisions. The idea is that if you go to my test file here, the idea is that I have a little loop and I can say gcassert BCE like this. And my test, or my linter, I guess, is going to make sure that there's no bounds checks inserted by the compiler for this line of code. It is a common thing if you're trying to make the code go really fast, trying to constantly make sure that these bounds checks are gone. But it's easy to let that regress. And so I wanted to make a linter that, given this comment, will automatically make sure that there are in fact no bounds checks. And it's the same for inlining. So in this other test, I've got an inlineable function here. And putting this comment, gcassert inline, is going to assert that this inlineable function in fact did get inlined by the compiler. So that's kind of what we're working on. But welcome to the stream. All right. So that being said, the next thing we were going to do is write a test for, we already have a test for the parser. Now we want to write a test for this like bigger function, gcassert. So we're going to call gcassert on test data, I guess. And now here's a problem, is like the output of this thing is actually, we're just printing stuff out. So I suppose what we really want to do is have like a writer. So that we can print to this writer and then assert that the writer looks a certain way afterwards, rather than, yeah, you can't really do it with messing with standard out. So instead of printf, we're gonna do fprintf, and we're gonna pass in our writer, which we named w. And I think the error from this fprintf we can just ignore. Eddie, how's it going? So comments are significant like C's fall through, or is this separate from the compiler? This is separate from the compiler. This is like just like a little tool that I'm writing to help myself in the future. To the Go compiler, I don't think comments are really significant. C's fall through. Is fall through in C a comment? I thought that was like a statement. I can't remember though. So we're gonna run our test, and we're gonna say, the writer we'll pass in is gonna be a strings.builder. I guess we can say var w strings.builder, and we'll pass in writer like this, and then we'll say, let's just print it out for now. So print line w.string to see what happens, because I'm not really sure what's going to happen, to be honest. Let's find out. So it didn't do anything, and I'm guessing that's because I've already set things up to work in a sense. So what I could do is make a assertion that I know is going to fail and see what happens then. So for example, I could say, no, I think actually, yeah. So for example, I could put gcassert BCE up here.
Computers hooked into over 1,000 data banks throughout the world.
And this is not going to get bounds check eliminated, because you've got to check whether 5 is less than the length of ints, or else you're going to have a problem and not be memory safe. Hey, Sergivos, thanks for the follow. Appreciate that. So let's find out what's going to happen. Of course, this isn't really a test yet. It's just sort of a program, but okay, still nothing happened, which is sketchy. Hey, Nam Taida, thank you for the follow. So it's sketchy that nothing happened. It was kind of forcefully pushed into most C compiler implementations newer. Oh, I didn't know that. That's actually really interesting. So for whatever reason, it looks like this isn't quite working yet. So I'm wondering why. Why don't we print out everything in this scanner line thing? Hi from scanner loop, just to make sure that we're actually getting here, because I kind of have a feeling we're not even getting here. Aha, can't load package test data, no Go files in blah, 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 blah. Ooh, it's because the package path is all messed up. That's kind of funky. I guess I need to pass in, but you know, maybe it's because I'm running this from the IDE. Let's just stop doing that. That's like a recipe for disaster. So I'll just pass go test dot. Okay, so my parse test failed because I edited the file. This is like really annoying, honestly. I need to figure out a better way to test this, because right now, every time I edit this test case, I have to go edit the line numbers in my parser test, which is pretty horrendous. So I guess this is gonna become 11 or something. And this is 8. Let's try that again. Okay, so that worked. And then if I pass -v, I'm gonna get those prints that I was looking for. So still the same thing. Can't load package, no Go files in this long path. That's kind of weird. I guess I just need to, instead of passing this relative path, I should really be passing
Computers hooked into over
whole
1,000 data
path?
banks throughout the world.
Yo, ASAP, Fred, I3, and Exotic Burger, thank you guys for the follows. It's a little annoying. Like, how do I get a relative path in this test case? Can I get one from T dot? Maybe I just need to say like os.cwd or whatever. Forget how to do that. Golang, current working directory. I always forget this stuff, man. Get WD. Like, why is it different? I don't know. Get WD. That's like kind of bizarre. Get WD. So I'll say dir error is equal to os.getWD. If error is not equal to nil, t.fatal error. Okay. And then I can say gcassert. I guess I'll just do dir plus test data. How about that? Is that going to work? Okay, so this is interesting. We got way more output than we expected, and it's including output from like the standard library packages, which is really no bueno. It's very unbueno. I don't care about output from the standard library packages, but at least it's sort of working correctly. So let's actually, what happens if I get rid of my little debug hi from scanner loop printf now that that's sort of working? Do we get the output that we care about? Yes or no? Still don't get any output. I'm not sure why. I guess what I could do next is debug these file path line no and message things. Oh, you know, I bet what it is that these file paths are not like properly relativized in a sense. Okay, let's do a couple things. First of all, let's get rid of this -a thing, because I think that's what's getting the whole standard library to be compiled, which is not cool. Let's put that everything printer back in. So we'll say format.println scanner, and then print out the line of code. So we still get a lot of standard library stuff, which is really uncool. Like, I don't care about that at all. I don't know why it's bothering to give me this stuff. What if I grep for, oh, there it is. Okay, so here's an example that is working. So scanner says test data /BCE. And then, yeah, so this is looking good. This is sort of what we were hoping to see. The question now is why we're not detecting these guys. Oh, you know, I think I know what it is. I think I know what it is. The problem is that I forgot to edit the compiler flags when I added that BCE thing. So like right now I think it'll work for inlining, but we didn't even add code for that. So really it's only checking bounds check elimination, but we didn't tell the compiler to give us the information about bounds check elimination. So we just need to pass in this big fat flag in our flags, I think, like this. And then I think hopefully it's going to give us more information. So let's try that again. Great. So it's saying found is in bounds for test data BCE line 8, which is exactly what we were hoping to see. The only thing that's unfortunate is that we still don't see any output from the assertion actually failing, which was what the hope was. So we need to figure out why that would be the case now. So I think why don't we go down here and we can just print out if we found any matches. So found directives for file and then pass in the file path. Let's maybe just get rid of this log line because it's so noisy. See if that does anything good. It does not do anything good. So the next question is, I think I know what the problem is. The problem is that when we were setting up our directive map, we're probably not including this whole path here. Could that be it? I'm not sure if that's it. Let's actually also print out the information about this regex stuff that we parsed out and whatnot. So we'll print out file path, line no, and message to see if that is lining up properly to what we think. So we see test data bce.go. Yeah, I mean, this is looking good. So it sort of looks like our regex is working. Then the question is, how come this doesn't fire? Why don't we print out our directive map first then? Yeah, I mean, the print line debugging is not so bad when the program compiles so quickly, I have to say. It's kind of nice to work on a small project like this. Okay, let's pass this into less. Okay. So our map actually has the full path. That's the issue. So it's like the complete absolute path. And what we have is a relative path. So let's see. I guess what we want to do is convert our absolute path into a relative path, maybe? And not the vice versa? That seems better, right? So what we'll do is when we have a file name here, we're going to say os dot, isn't there like a make relative or something like that? Forget how that works. Let's see. So Golang make relative path. File path dot rel, base path and target path. Okay, so I think if I say up here, cwd is equal to os.getwd. If error is not equal to nil, we can panic. And then I'll say, so this will say, instead of file name, comma, I'll say abs path. And then I'll say rel path is equal to file path dot rel current working directory, comma, abs path. Does this also give me back an error? Yes, it does. Error is not equal to nil. Let's panic. I don't know. I think I probably should be propagating these errors, but for now, I'm just not going to bother just until we get stuff working. Okay, let's try again. Can't make test data.bce.go relative to gcassert. But why? That sort of seems like the exact thing that you could make it relative to. So main.go line 198. That's a little weird. So maybe, like, are these abs paths really abs? I could have sworn they were, right? Because we just saw that. What else does file have? Or what else does package have? Package.files, name, scope, imports. Well, it's slightly confusing because here it sort of appears that, well, let's print out the path that we get back. So print out that abs path and our current working directory. So our abs, wait a minute, this does not look abs at all. How did it turn into an abs path then? That is so confusing. Hold on, let's comment this stuff all out. We have to pipe through less again. So up here we see, oh. Okay, so when we run it via test parse directives, we somehow have relative paths. But when we run it through test gcassert, we have absolute paths. So there's some difference that I need to determine. So this test, man, this is annoying. It's kind of like parse dir is doing the right thing, but oh, I guess this exec.command thing needs to get a better working directory, something like that. How do I set the working directory of exec.command? That sort of seems like the issue. I guess we could look up the documentation for it. Exec command cwd. Oh, I can just set it. Okay. Man, that was silly. Okay, so let's go back and undo this rel stuff. And let's also just pass in the rel path to gcassert, because that was unnecessary, I suppose. So over here, we'll just say cmd.dir is equal to os.getwd. Well, we need to, again, capture this. Okay, so let's see. Maybe this is going to help matters a little bit. Maybe this is going to help matters a little bit. So let's run again. Okay, so we're getting relative paths, which is great. So we've made a little bit of progress. But the next question is, again, why do we not get any prints from where we're really expecting to see some matches, right? So here in our loop, the whole point is that we're checking. Hey, Pragmatic Lou and F user Hamza, thank you for the follows.
The computer's hooked into over 1,000 data banks throughout the world.
What's the deal now? So the deal now seems to be that. Let's run again with our whole. Wait.
Computer's hooked into over 1,000 data banks throughout the world.
Always remember to do that. So now I'm just getting another issue with actually being able to compile this at all. Hey, Mr. Willow Street, thank you so much for the follow. So it's saying cannot load package test data, no go files in this again. Okay, so this is that same problem about not passing the proper thing into invoking the compiler in the first place. This is very irritating, I have to say. It's really quite irritating, I have to say. Let's see. So running go build from, then I'll pass in this CWD thing. So this seems good, right? Running go build from this file. That's what we wanted. And then how come it complains about this? I don't get that. I don't get that at all. Maybe, do I have to include like a ./ or something? Could that be the problem? That was the problem. I needed to include a ./. All right, okay, so we're actually getting some good output then. It's looking a little bit different than what we expected because this AST printer gives me like this giant dump of stuff instead of just like the line itself. But we are getting an assertion failed, which was the whole dream. So I think that's some good progress. So let's see. Basically what this is doing, if you're just joining, is it's noticing in this test file that this line of code here where it says ints of 5, this ints is a slice and 5 is just an arbitrary integer. And because it doesn't, the compiler at this point doesn't know the length of ints, it has to emit a bounds check. And I've added this assertion, this gcassert BCE thing, which is what my tool is searching for, that says, if I see a bounds check for this line of code, please let me know because it means that I've done something wrong. So my tool is correctly noticing that this thing is getting bounds checked, even though I have the assertion. So hooray. Now I think we just need to make the output look a little bit less terrible. So the first step for that is going to be removing a bunch of these extra print lines. Like we don't need this, and we definitely don't need this, and we definitely don't need that giant one that prints out everything from the output of go compile. In fact, we just don't need any of these prints except for the last one. So let's run it one more time. This should look a little bit nicer. Oh, right. Except we still like pretty print this whole AST, which is gross. But it's saying, I mean, ultimately it's saying the right thing. It's saying assertion failed, test data BCE 8 found is in bounds. You know, maybe that's fine, and like we don't even need to include this whole. I think it's actually polite. I think it's polite to include the line of code. It's just I don't want it to look like this. Like, how do I get back the original line? Perhaps there's a way, instead of doing AST pretty printing or whatever, if I just said like, maybe like the F set has some way of giving me back a particular line. Guess not, but maybe like the file does. I mean, I could like reach back into the file and like just go to the position and print out that line. Is that how you're supposed to do it? Seems a little gross. If only there was a way to just ordinarily pretty print the particular line instead of just like dumping this entire tree. Pragmatic Loose says, nice keep, thanks man. You can hit that to get that info. I don't know how to make people realize they can do that. I'm always typing it myself, I feel like. I'd really love it to be able to just print back out the line without printing out that whole tree. There just has to be a way, right? Golang, print AST node. Maybe do they have string methods? Maybe it's just like I'm just like overcomplicating things by using this fprint and like info.n already has a dot string or something. Definitely does not. Printer.fprint. This looks potentially promising. What's so cool about the Go documentation, you guys? Oh, wow. Well, I was going to say it's cool, but it looks like somebody didn't set this up properly. But all these examples are pretty nice because they are actually runnable most of the time. But I guess in this case, something got a little bit wacky. So maybe this printer thing, instead of just using the ast.fprint, maybe there's like printer.fprint. And this takes what? An fset and a node. Let's try that. Maybe this is the way to do it. So underscore is equal to printer.fprint buff file set info.n. Maybe it's just the wrong AST or the wrong API rather. Let's try again. There we go. That is looking better. That is looking really nice. So let's see. Like I guess the last thing is that we just need to get rid of that last extra print line that we have for no reason. Get rid of all this. Clean it up a little bit. And that's like, yeah, you know, that's looking pretty tight. I guess it's a little bit unfortunate that like there's a sort of a few problems here. We have two lines when we could just have one. We really would prefer to say like assertion failed, test data BCE.go, maybe like this whole thing and then this message, something like that. Let's try that. Just let's try it on for size, shall we? So we'll say assertion failed. We'll say this buff, and then we'll say the thing that the compiler told us, like that. So we'll say buff.string and then the message. Get rid of that altogether. What does this look like? Assertion failed. Formatted print line into 5 found is in bounds. That's pretty good. That's pretty good. So let's actually go ahead and add just that So we did it for, right, we did it for bounce checks. Now we just need to do it for inlines. And then I think we'll be sort of done for this, at least the goal. Well, we probably want to write better tests too, but the goal that I wanted to get done was basically having inline and BCE assertions. So if we see, what is the message we have to search for inlines? It's this, inlining call to. And I think it's just that, right? So I'll say if strings.starts with or begins with has prefix, okay, has prefix message inlining call to, right? Inlining call to. Then we do the same thing. We print out this assertion. And I guess, you know, what we should really do is make this into a little method. So we'll call this print assertion failure. So print assertion failure, we'll pass the file set, we'll pass the info, we'll pass the write, we'll pass the message. Just the whole thing. Easy. So now I think hopefully if we run this again, we'll see 2 failures. No, we'll just see. Ooh, you know what's interesting is this one's actually the opposite, right? This isn't supposed to be a failure. This is supposed to be a pass. So it's more like if strings.has prefix yeah, what the heck is this? So it's actually like we need to assert the absence of a output for this one, right? So yeah, we actually, it's a little gross. We have to loop in 2 directions. We need to loop over all of the compiler output. And then we need to loop over each of the directives, I guess. So really what we want to do here is like mark our info map or something like that. And then iterate all over the directives again later, basically. So we can do that. That's no problem. So this line info is going to get another piece of information, which is, well, you know, maybe what we need to do is actually have instead of just having a slice of raw directives, we need to have a slice of directives and like Booleans, which is whether they were ticked off or not, essentially. Is that right? It's a little messy. I don't love it, honestly. I guess, I guess I could have a parallel slice that's got a Boolean for each of them. Or I'll have a map, maybe. A map from the index into the assert directive to a Boolean if it's like necessary or something like that. Let's do that. So we'll say found or like failed directive or something. Map from int to bool or something. It's really like, no, it's not failed directive. It's, let's see. So it's the case where finding a compiler output line means that you should not fail the directive. So it's like past directive or something like that. I don't know. It's a little nasty. It's a little nasty. Past directive is a map from index into the directives slice to a Boolean that says whether or not the directive I guess it could just be a slice, right? Well, whatever. Well, whether or not the directive succeeded in the case of directives like inlining that have compiler output if they passed. For directives like BCE that have compiler output if they failed, there's no entry in this map. Something like that. So instead of printing the assertion failure directly here, what we have to do is say info.past directive of I, and we have to capture this I over here, is equal to true. And then we loop back over our directives. So for I in range directive map, I guess it's for line to directives in range directive map, for info in range line to directives, info dot, right? So then it's like so many loops for D in range directives or info dot directives. And then we only want to do this for inlining, I guess, in this case. Inlining has negative, positive matches. Let's see. On inlining directive passes if it had compiler output. For each inlining directive, check if there was matching compiler output and fail if not. So we'll say if D is equal to inline, if not info dot pass directives of I, then at long last we get to print assertion failure like this. At this point we don't have the message left, do we? I guess we don't need one. We can just do blank. All right, solid. Let's try again. Assignment to empty entry in nil map, right? Well, you know. Guess we'll say if info dot pass directives is equal to nil, info dot pass directives equals make map from int to bool. Alrighty, what about now? Okay, we still get assertion failed on this one, which doesn't make any sense because we did get a pass for this one, right? Right, it's because we, is it really because we don't assign back? Yeah, it is. So we have to say line to directives. It's so annoying working with maps in Go, I have to say, because you have to do this reassignment junk. It's really irritating. I guess you could put a pointer and then you wouldn't have to do this, but it's not common practice, I want to say. There we go. Okay, very cool, very cool. So then the last step is to just make a thing that can't be inlined, right? So func not inlineable. And I'll put in, I don't know, a int. And what's something that can't be inlineable? Anything that has a for loop, I think, can't be inlineable. So I'll say for I is equal to 0, I less than a, I plus plus, format.println I. I think this one definitely cannot be inlineable. So I'll say sum plus equals not inlineable of I, and I'll still put the assertion, and then this one should fail, hopefully. So ignore this failure for a second because that's about something else. Assertion failed, sum plus not inlineable. And I guess in this case, we do want to supply a message in our output, which is going to be like print assertion failure, file set, I guess it's like call was not inlined, basically. Cool. Yo, Makin8, what's up? Thanks for checking out the stream. So I guess we just need to fix our parser test and then maybe convert this last thing into an actual test, and then we should be good to go. So this one now, I guess
computers
there's like
hooked into over 1,000 data banks throughout the world.
On line 13, I think it was. Yo, Aeroduck, thanks for the follow. So what happened here exactly? I guess I just changed some line numbers basically, right? So I need to have one on, oh yeah, because I added this whole function. So I have one on line 20 and line 120, on line 22 now. So it should be 20, this should be 22. Cool. Very good. I guess we should also have a test that two things, if there's anything that's got two assertions, that they get checked as well. Is the audio scratchy? I hope not. What do you mean by scratchy? Tell me more. So an example of something where we could have two callers would be, let's make a function here in bce.go. Why not? Audio is good for Makin8. Thanks for telling us. So func inlineable a int return a+1. So this is definitely going to be inline. Oh, right. We already have an inlineable function in this file, so we can just call it. So we'll say sum plus equals inlineable of ints of I. And then if I say gcassert inline, I think hopefully both will be checked. Control Shift R, fix it. Awesome. That is good to hear. Sometimes that happens. I don't really know why Twitch does this sometimes, but it does. So in our test data, we need to change some stuff again. We need to change this 11 to be 12, and it's got to have both directives like this. I think that'll pass. And then I guess the last thing is we just need to have a test that the assertion error gets printed out for both types of failures, if there is one. So how do we do that? I guess what we want to do is similar. We can have sum plus equals not inlineable, and then put the assertion on both, and then the assertion should pass in one and fail on another. And I guess we need another thing like this to make our parser tests pass. Cool. So I think this is looking really good. I think what we need to do now is make our test gcassert test actually assert stuff. Right now it just prints some stuff to the console. I think what I'll probably do is just like hard code the output, because I don't think I care that much. So I'll go to gcassert test. Instead of printing out w.string, I'll just say, you know, I'll just kind of grab this text. You know, this might be a good time to use that data-driven library, though, to be honest. Would that be easier or harder? I think it might be easier. Because what that would look like is... What that would look like is like... Let's take a look at what that would look like. Why not? Okay, so what I think it would be is I would say something like... Ooh, you know, I think it actually would be hard, though, because I still need to have the Go compiler run against these things. All right, forget it. Forget I said anything. I'm just going to hard code what this looks like. So expected output is equal to... I'll just paste this in, basically. It's not ideal, but whatever. And then I'll say assert.equal t expected output, and then the actual is going to be my w.string. Then if I rerun, I think both of the tests should pass. No. expected new line assertion. Oh, do I just have an extra new line in here? Yeah, that's the issue. Go test. Still some differences. Again, it's something to do with new lining. Oh, or is it to do with map iteration order? Is that annoying or what? There's also another problem, which I'm not printing out the line number anymore. I have to get back to printing out the line number. So hold on, let's fix that first. So where I print out, where the heck is that? Print assertion failure. Okay, so instead of just printing out the line of code that's failing, I think I need to also print out like SD like this or something, and then put info dot, wait, what is it again? It's like file set dot position of n dot info dot n dot post, right? This gives me back a post is equal to this, and then I think I have, what does this give me? It's give me a line and a file name. Great, so I think I just need to put post dot file name, post dot line. What does that look like now? Assertion failed, test data BCE. I don't know if it looks so good to have this whole big assertion failed prefix. Probably I just don't even need to print out assertion failed at all. And then we're really going to be cooking with gas, my friends.
Computers hooked into over 1,000 data banks throughout the world.
Yo, Java is best. Thank you for the follow. I don't know if you're trolling me trying to say the words Java is best out loud, but you got me to do it. How do you feel? It's a little gross that these aren't aligned as well. Should we put like some tabs in there or something? That's looking a little bit better. It's not going to fix it in every case, but it's a little bit better. All right, I like this. Let's grab what this is supposed to look like and put it into our expected output. I've got these pluses for some reason. I don't know why those are there. Okay, what about now? Oh, right, we still have this iteration order issue, I think, right? No, it's that I still have a plus in it. I still have a plus in it. Okay, please pass. Yay, okay, cool.
Computers hooked into over 1,000
Cool.
data banks throughout the world.
Yo, Ezra Flag, thank you for the follow. All right, so let's make a commit with this real quick. So let's do add 3, 4, 5, 8, 7, like add everything. Let's make a git ignore, stick .idea into it. Let's add that. So we're gonna say git commit. We're gonna say, let's see, initial implementation of gcassert. And we're gonna say gcassert searches for cases where, well, searches for, let's see, add to assertion comments, gcassert inline, gcassert BCE. Let's see, inline checks to see whether the following line had an inline function or not. I guess I should say asserts that the following line has an inline function. BCE asserts that the following line has its bounds checks eliminated. Cool. So we can push this. By the way, if you want to follow along, I don't know if you do care to, but if you do want to follow along, this is all living in github.com, Jordan Lewis, gcassert. So I'll paste that into the chat. It's just a brand new repo. It doesn't have anything in it yet, but Well, now it does. But you can follow along if you feel like it. Okay, so the next step, I guess, is going to be making the actual tool, right? So I have this whole bunch of code here, but I don't have like a command line binary, which is sort of the hope, I think. I want to be able to say like /gcassert and then pass in a package, and then it's going to search through that package and run all of these checks against it. So I think I'm going to set that up next, but first I have to quickly take a break. So give me 5 seconds and I'll be back. Don't go anywhere. I'll be right back. Okay, I'm back. Thanks for sticking with me. Okay, so here's what we're gonna do next. We're gonna make this little command line tool real quick. Yo, JS Digital, thanks so much for the follow. So let's see. It's been a little bit. How do I write a main function in Go? I guess first thing, let me quickly make a new file and stick all of this stuff into it. Like we can call it, we'll just call it gcassert. How about that? Gcassert. Just gonna paste everything into this so that main can just contain the actual code or actual command line tool, basically. Hello, IDE. Why you pausing on me? Yo, Jason, what up? How are you doing? Happy Sunday. Hope you're not having any Sunday scaries. What is that hi emote? I like that. Lana Lux. Lana Lux. She's like this is game dev girl, right? I've never really watched her stream, but I've seen her on around. She has like a huge followership. Okay, so here's what we're gonna do next. We're gonna say a func main. Guess this needs to be. Oh yeah, you know what we actually do here? What we actually do here, the like cool thing to do. The cool thing to do is going to be making a make dir command, or I guess it's make dir command gcassert -p rather, and then in that we have our package main. I think that's what like the cool thing is to do. So, so we'll say touch command gcassert main.go. Unclear why that was just completely empty, but is there like something funky with this setup? I don't think so, right? Now what is a main function supposed to have in Go again? Does it, I don't think it's supposed to have anything, right? Like you don't need to pass in the like args and stuff. That's like some C stuff, right? I think what we need to do though is like, there's this like flag.parse stuff we need to do. And I guess, let's see. So what are the flags that we actually need to care about? Literally the only thing that we need to do here is pass in a package path, right? I want to say yes. So
the computer's hooked into over 1,000 data banks.
How do I get my args at? Flag of arg 0. Yo, Indifferent Ghost, thank you so much for the follow. So we're gonna say package path is equal to flag.arg. And we're basically just gonna say gcassert of package path and this thing is going to take a writer, right? So I guess we can literally just pass in os.standard_error, right? Is that like literally all there is to it? So let's say, let's find out. We'll say go build /command gcassert. We have this gcassert binary, and what if we pass in dot? What do we get? Open no such file or directory. Okay. Okay. What is the deal with that, huh? Line 12. Wait, what? gcassert line 109. So let's make this thing return an error, shall we? Let's not panic everywhere. Let's fix this up. So we'll return error, return error. No more panics. Panics are done. We can get rid of this thing. Let's make a name for this. So gcassert searches through the package is... Yeah, so that's another thing. I'm not exactly sure. Like, there's this thing for like package specs, right? It's like the packages at path, at the input path, and writes failures to comply with gcassert directives to the given io.writer. Basically what it does, right? So then up here in our main, we'll say error is equal to this. If error is not equal to nil, we'll say, I guess we just, what do you like, what's like the canonical thing to do if you have an error to return in a command line program? I don't really remember. You just say, I guess it's just like format fprintf os.standard_error, something like that. Fprint. Return -1. I don't think that's like a thing. It's like os.exit -1, right? Or I think it's just 1, right? -1 is like some other stuff. I just mean, like, it's a good point, and thanks for that. I just, like, I'm trying to remember how are you gonna print that error to make it sort of appear normal. So we'll do go build again. Okay, so it says no such file or directory. Looks ugly. I think we need to put a new line. Log.exit, is that a thing? Log? What the heck is log? I don't even know. I don't like know basic Go. Log.fatal. That's like a thing, right? What happened if I log.fatal this error? I don't like that either. I'm just gonna keep what I had. Okay, so the question though is, you know, cannot open empty, no such file or directory? What is the deal with that? I think it's like I'm not using the right, I think this needs to be 1, right? Arg returns the ith command line argument. Arg0 is the first remaining argument after flags have been processed. Arg returns an empty string if the requested element does not exist. 0 does seem good. I think I just didn't, I need to do flag.parse. Okay, let's try this again. Okay, so this is like, it seems like it's doing something. And what if I pass in test data? Yo, you guys, check this out. This is actually kind of sick. This is the dream. We're living the dream. I think the only potential non-dream that we're living is that I would really like this to recursively work. Actually, let's try running this on Cockroach, why not? Because this is the entire point. Day job, I work on a database, CockroachDB, and I wanted to have this thing for my database. So let's go into that repo. I guess we can say go install command gcassert. And if I say gcassert, then I pass in package SQL call exec, what do I get? Well, obviously I'm gonna get nothing because I didn't put any annotations. But the question is, what if I put an annotation? real slow because there's a lot of code in this, I guess, but that's to be expected. It's really quite slow. I guess it takes a lot of effort to compile all of this code, right? Like a ton of effort, because it's not just the code in the package that it's having to compile, it's like all of the dependencies and stuff like that. It would really be nice if I could tell Go build to do the same thing that gotool compile does, which is not run the linker, you know? If I could have it not run the linker, this would go so much faster. I wonder if there's a way to do that. Go build, don't run linker. What if I like pass in just like a fake linker using Let's read the docs for this Go help build guy. LD flag is not what we want. Name of compiler to use. What about the name of the linker though? I just want to pass a nil linker. Doesn't seem to be possible based on that. To LLD using link flags. Cgo LD flags equals da 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 da. I don't know. So here's the thing. The thing is that like I could theoretically construct a, so that finally finished, it just took forever. So let's make one that fails just for the purposes of argument. We'll check out this dude here. And I'm going to go to a case where we don't have any bounds checks. So like this one, for example, if I said gcassert BCE here, this should fail because this is not going to get, well, the compiler doesn't know how big output call is yet. I happen to know. So I think if I run my tool on this again, it should eventually tell me that I have a failure. And by the way, I think that I should have the tool return, if it has any output, it should return, you know, exit code 1 or something, so that something can programmatically detect when this stuff is busted. Yo, Arsenix, thanks for stopping by. How long did it take me to get my first job when I started programming? I got a programming job right out of college. One thing that I did in college that was kind of like a job is Google Summer of Code. I don't know if you've ever heard of that, but it's a great resource for starting out programming, I think. Or I don't know if it's starting out programming, but it's like, if you really want to get into open source development, find a project for Google Summer of Code and contribute to it. So I contributed to Vim, which is awesome. One of the coolest experiences of my life, I want to say. I added undo persistence to Vim. So if you know what that is, I got to work on that. I got to add that to Vim back in 2010 or 2011. So that was kind of, I think, my first paid programming gig, probably. But I sort of had a hobby of programming since high school and stuff like that. Linux kernel convention is 0 if success and a negative number if there's a failure. Sartak with the master Mitch Flower Power emote usage. Okay, so I'm gonna say, I guess what I need to do here is like, instead of writing to os.standard error, I need to write to a buffer. So I can say var buff string dot, or strings dot builder. And I'll pass in buff. And I'll say output is equal to buff.string. If len output is not equal to 0, well, I guess I'll say f format dot f print line, f print os dot standard error output, and then I'm gonna say if it's not equal to 0, then os dot exit. 1, -1, I don't know. Conventions, I don't know. I see what you're saying, I just don't know the answer. Okay. So this didn't seem to work, confusingly. A little bit suspicious. Let's go install this guy again and run it on test data. Okay, so that's working. It's returning 1, which is expected, or I don't know. These Go tools, like, they all sort of work in the same way. Ideally, I would figure out what the other Go linters do when they see a failure and return that same code, but I don't remember what it is right now. Yeah, you know, how come that didn't work, huh? Maybe it is getting bounce check eliminated. What about what about something that isn't getting inline for sure? Like this thing is not getting inlined, right? It's way too complicated. gcassert inline. Run on that. And then if I run gcassert dot, I should get 0 exit code. Very cool. I am into this quite a bit. Okay, so let's do git add 2, 3, 4. I'll add gcassert itself to the git ignore. I'll say git add 4, git commit, add gcassert binary. I guess I'll say add command gcassert.
Data.
Yo, attention core, thank you so much for the follow. Running gcassert on a package will print out any gcassert failures to standard error and return a non-zero exit code if failures were detected. So push that guy up. This thing is still chugging away. It is quite slow. Hey! Okay, so it totally worked. This is sweet. So it's saying this particular call was not inlined, which is true. I think the last step here would probably be to add a README, or like edit this README to not be so terrible. But I think I need to probably stop in a hot second, so I think I'll do that off stream. But again, if you are interested in this work and you want to check it out further, check out the GitHub repo.
Data.
Yo, Lang Cowie01, thank you so much for the follow. But yeah, I think I'm probably gonna wrap up. Thank you guys so much for tuning in. It was a lot of fun. I thought this was a good stream. I like the Golang focus. I think I'm gonna do this more on Sundays. So I think Fridays are gonna be CockroachDB related development. Sundays are gonna be Golang related development, or just like other stuff. And if you are enjoying, please come hang out again. It was a lot of fun. Let's go find somebody to raid. And say hello to them. But yeah, you know, if you're enjoying, give me a follow and turn on those notifications, and you can see when I stream. It's mostly Sundays and Fridays. I think it's only been Sundays and Fridays so far. But does anybody have somebody good to raid? I don't see somebody that I particularly know that well. Let's see, what about this person?
Database.
Yo, RV Santos, thank you so much for the follow. It went from 0 to done in a couple of hours. Yeah, that is the dream, right? It's like you get, if that can happen, it's rare, but awesome. I feel like most of the time I go from 0 to like mostly still 0 after several hours. So who should we raid though, you know? What if, okay. Let us hit up this person here. You know, this looks kind of sick. Okay, CM Griffin G, ready? CM Griffin. This is always a gamble because I don't really know what these people are doing, but it should be exciting. Say hello, be nice to this person. Looks like they're doing some Rust stuff. Wasm, Rust, it's exciting. All right, so see you next time. Thanks so much for tuning in. Have a great Sunday. Have a great rest of your week. Goodbye.